All right, thanks, Maya. I think we decided to call it Uber and security, but then we were Uber X security because.
No, I think the title is actually how we built our workload identity platform. So that's my bad for not putting it up there.
All right, sweet. Well, thanks everyone for making it here in the last session of the last day of KubeCon. And can we have like a round of applause for the program committee and the track hosts and everyone who makes this whole thing possible? Sweet. All right. So we're going to get started.
Right.
Yeah.
So Uber and security. So the title, like I mentioned, subject is how and why we built out our workload identity platform. I really want to focus in on the why today, and the how will come. So when we talk, so I'm Tyler Julian. I'm at Uber right now on our identity and access management team. And actually, I should probably just grab this clicker so that I can. I'm on our identity and access management team. I've been working here for a couple years on our authentication and identity frameworks. Prior to that, I worked on our trust and safety team building distributed applications. Daniel?
Yeah, and I'm Daniel Feldman. I am currently at Scytale. I've been there for about a year, and we're a whole company that is built around the concept of workload authentication and workload identity. And in my past life, I was at a company called Veritas, which makes backup software, and I did all the workload authentication for Veritas backup products, which is sort of how I developed an interest in this subject. It's back to you. Oh, and you can follow me at D_Feldman, not D Feldman, that's someone else. And Tyler doesn't have a Twitter, but he does have a Spotify with his own originals, so you can follow him there.
Yeah, you got that.
All right, so today we're going to talk about 4 sections of our talk. The first is the identity problem at Uber. This sort of, you'll get an idea of the scale of the infrastructure, the scale of the problem at Uber, which is all news to me because I've never worked at Uber. And then we're going to talk about SPIFFE and SPIRE, which are Scytale's solutions to the workload identity problem. Then in part 3, Tyler's going to do a case study, sort of an example of how a growing company can end up with a big workload identity problem. That company may or may not be Uber. You can't talk in too much detail about Uber, but it's probably related to Uber. And then we're going to have plenty of time for a Q&A at the end.
Cool. So.
Is it not working? All right.
We'll have to wing it here.
Just wave at me.
Yeah, we'll wing it here. All right, so identity at Uber. So I wanted to kind of set the stage for how we came upon this problem of identity, what led us to get there, what sort of business value does solving identity get Uber. So just to give you a rough sense of the scale, we've got about 3,000 unique services that we run at Uber. Not all of these are specifically for ride sharing, but these are sort of in support of Uber as a business. And what that results in is roughly 400,000 containers running at any time to support those 3,000 services. So when I'm talking about services, primarily stateless workloads. We run about 100 million batch workloads every day. And this doesn't even capture all of the stateful storage that we also run as well. And so we're moving a tremendous amount of data, right? And so where does this data run on? Here's a little picture of our infrastructure. We have deployments in both the cloud and on-prem data centers. So we have data centers in the US, and we also have cloud zones across a couple different providers. The way that data moves over RPCs is generally gRPC, although actually the lion's share of our traffic is HTTP and a custom protocol we wrote called T-channel that we've open sourced. That's a lightweight framing protocol on top of TCP. And with that comes some custom routing and discovery as well. As for orchestration, workload scheduling, that sort of thing, we do use a fair amount of open source, Mesos, Aurora, as well as Hadoop, with some in-house glue to kind of make that deployment a little bit smoother. Services written in Go, Java, Python, Node, and even more than that. And so what has allowed Uber to achieve pretty massive growth has actually resulted in an infrastructure story that to date hasn't been super coherent, right? And so we can't rely on Kubernetes-specific tooling that we've seen at a lot of the talks this week. But a cloud-native approach actually does serve us quite well. And we'll get into exactly what that looks like. So when we talk about identity, there's a lot of things come to people's minds. The first, of course, is humans. Human identity, when we talk about humans, we're talking about users. Users are riders, drivers, couriers, customer support representatives, engineers, managers. It runs the gamut. People think about OAuth, two-factor auth, all that sort of thing. When we talk about identity for machines, we're talking about routable hosts within our infrastructure. When we talk about identity for workloads, this is really the meat and potatoes of your business. These are the things that are the applications that are running business logic. And these are things like your stateful storages, your stateless services, your daemons that might be running across your hosts and your batch jobs. And so workload identity is really what the focus of this topic is, and we're not going to focus too much on the other things. So what does it mean to have a workload identity? The goal in my eyes is to be able to uniquely identify a particular application. But say you have one service and you have 100 instances of that service. Is it particularly useful to know one instance versus another instance? Well, every instance has roughly the same permissions. So differentiating on an instance-by-instance basis is probably not super useful. But being able to uniquely identify that service, that seems like a powerful construct, right, for controlling access. Now, you might have that same exact service running in staging or running in production. And creating a distinction on that scale also seems to be important. Right? And so when we talk about uniquely identifying a service, it's sort of with respect to the types of access decisions that you need to control. What I get to next is that having this unique identity allows you to control access to things like database credentials, third-party APIs, even controlling access to other services. There's an argument to be made that things like credentials and APIs sort of become irrelevant if identity is super ubiquitous, but we won't get into that too much today. What identity also allows you to do is to protect data with encryption in transit, which is going to get you confidentiality and data integrity. You know nobody's eavesdropping, and you know nobody can change your data in flight. It's super critical. It also allows you to control access through authenticity and authorization. You know what is accessing the data, and you can manage that access. One thing to note, though, is identity by itself doesn't necessarily get you encryption. But when we talk about identity and identity documents, this often manifests as an X509 certificate. And so the protocol of TLS and that sort of thing sort of come as a byproduct of that. So when we talk about the business value of identity, one of the first things that comes to my mind, just based on a lot of conversations that I've been in, is compliance. And kind of the most relevant thing there is GDPR, which went into effect last May, about a year ago now. And this GDPR talks a lot about how you need to manage access to user data for the purpose of privacy, which is pretty important. And being able to tell a coherent story around data access for your user data, or for any data for that matter, it comes down to having a base that's rooted in a strong identity. Because if you don't have that, it becomes very hard to tell who's actually controlling data and who's actually accessing that data. Sarbanes-Oxley, if you're not familiar, is a regulation in the US that applies to publicly traded companies. And it's very similar, but the data story is more around financial data that's super important there. Beyond the compliance story, there's your trust and your security model of your systems. Being able to reduce the assumptions of your system behavior is very important for developing what we call a zero trust network. It's sort of been common practice that inside your secure perimeter, you expect that things behave correctly. But this expectation, as we've started to see, is not always accurate. And threats come from outside your secure perimeter, but also often inside. And so what this gets you is you can reduce the risk of unauthorized access in the case of a compromise. But you can also reduce the risk of bad configuration. It's not common for developers to test against production in very kind of, I won't say unsafe, but it's a bit dubious the way that a lot of developers these days talk to production. And so being able to have identity that can control access to your data, you know that dev isn't talking to prod, or if it is, maybe it's only has access to read certain types of data. So with that, just to give you the background of why identity is important to us at Uber, I'm going to pass it to Daniel, who's going to talk a little bit about SPIFFE and SPIRE and identity there.
Sure. So Tyler's introduced us to the scale of the identity problem at Uber, and now I'm going to talk about solutions for workload identity that we're working on at Scytale and Tyler's working on at Uber, and those solutions are called SPIFFE and SPIRE. So SPIFFE is the spec for a way to do workload identity and authentication, and SPIRE is an implementation of that spec. Oh, I just got louder. SPIRE is the code. SPIFFE is a text description of how to do workload identity in a particular way. Before I get into that, we're just going to talk for a moment about what makes a really good workload identity, because it's important to really think about what makes a secure identity before we start implementing identities all over the place. So this is an example of a not very good identity. It's a name tag, which could have any name. You write it on your name tag, and it's just a first name, so it's not particularly unique. Clearly, we wouldn't rely on that as a secure form of authentication. But this is something we would rely on as a secure form of authentication. And that's, oh, that one's very bad. But the other one is good. The reason we would rely on a government ID is, first of all, it has some unique information in it. So it's unique to a person, which is the unit that matters. Each person has one identity, and each identity corresponds to one person. It's stable over time. You can't change your government ID every single day. No, obviously that seems a little bit silly for people, but for workloads where you have hundreds of thousands of containers that are spinning up and spinning down all the time, you want them to have the same identity depending on what workload logically makes sense within your organization. It's verifiable, so you can go back and check that a government ID is a real government ID. Has some mechanism in there, maybe a hologram, maybe a code that you can check. And that's the same thing we would want for a workload identity. And the identity comes from some kind of source that we trust. For a human identity, it might be the government, because we believe the government isn't going to make a whole bunch of fake IDs. But for an organization, it might be some unit within that organization that has the power to grant identities to things. So how do we implement this for workloads? Well, first of all, it starts with an ID, which looks a lot like a URL. It's called a SPIFFE ID. It looks like a URL. It's not a URL. That's not a resolvable host name necessarily, but that part in green, in neon green, is it's called a trust domain. So it could be the domain name of your organization. It doesn't have to be. But everything under that trust domain is a single unit of trust that it is traced back to someone granting those identities. And then everything in blue, that's essentially a user-defined identity for that workload. So in this case, you could have /billing/payments. There's no semantic meaning to the directory structure or anything like that. It's just a name that makes sense for your organization. And then you can encode these IDs in two different ways. You can encode them as an X509 certificate or a JWT token, if you're familiar with JWT tokens. The X509 is maybe the most useful, because then you can use that to establish mutual TLS connections between all your services. And the JWT token is useful for situations where that really won't work. And then the other part of SPIFFE is you have all these identities, and you need some standard way for a workload to get its own identity if you want these to be interoperable. So we have this thing called the Workload API that gives you a way to, first of all, get your own identity document, and second, get the information that's necessary to check other identity documents. So you're running in concert with 3,000 other services. You need to, first of all, if you're one of those services, you need to get your own identity, and then you need to get the information that's necessary to validate any of those other identities. the public key information to be able to do that. Now, we're just going to stop for a second. This is all about authentication. SPIFFE and SPIRE and everything we're talking about today, we're not actually making a decision about whether one service is allowed to talk to another service. We're just providing the information to the service of who they're definitely talking to. And then it's up to you to figure out some kind of authorization that makes sense for your organization. So maybe the user's database can only talk to the billing database and it's just hard-coded. That's one way to do it. Or you could have a proxy, a smart proxy that maybe is talking to OPA and making some kind of complicated authorization decision. And there are all kinds of examples of different ways to do that, but that's not part of the specification. So SPIFFE is seeing a little bit of adoption, pretty rapid adoption actually. It launched officially in December 2017, at least according to the information I found, and it was accepted into the CNCF sandbox in 2018. It's already been integrated into a number of different open source projects, or at least is being worked on in a number of different open source projects. And a number of companies are working on deploying it, including Uber, which is up there. Now we're going to move on to SPIRE. SPIRE, remember, is the reference implementation of SPIFFE. So someday, hopefully, there will be many different interoperable implementations of SPIFFE. Right now, SPIRE is the one that we're working on and is the most complete implementation of SPIFFE. And you can see it's on GitHub. You can check it out. There's a link at the end of this presentation if you download the slides. And what SPIRE does is it has a number of different kinds of plugins that will all talk to your infrastructure, and we call that attestation. We talk to your infrastructure and then give you an identity that's based on that infrastructure, and I'll go into what that means in a second. There are other ways you could do that might also work with SPIFFE that wouldn't involve attestation. You might not have to talk to the infrastructure. You might do something totally different. So this is just going to be a very quick architecture diagram example. Let's imagine we have something running inside Kubernetes, and that's inside AWS. So we have some workloads up there on the top in blue, and we want to get them some kind of identity. First of all, the SPIRE has two different components. There's something called the agent and something called the server. The server has all the key material for generating identities, and the agent sits there and does most of the work and talks to the workloads and gives them their identities. So the agent can go out to the infrastructure and verify based on criteria that you supply what identity the thing should have, and then it will communicate with the server and give it an identity. So here are some criteria. These are just made up criteria for assigning an identity to a workload. But we could say it has a particular AWS security group, a particular Kubernetes namespace, and a particular Kubernetes service account, and that all corresponds to one identity. And I just made up an identity that says uber.com/users. And then the SPIRE server will generate that identity, and then it will feed it back to the workload up there. And the workload will then have access to its own identity. And then it has to do something with that identity when it's creating connections, when it's receiving connections to authorize based on that information. Now here are some goals of the SPIRE project. These are all in progress. It's all work in progress. But it should be fully automated, so no one is deploying certificates manually in this whole system. There's minimal knowledge, so if any part of the system is compromised, hopefully nothing leaks out that we don't absolutely need in that component. So if you compromise the SPIRE agent, you can get some information, but only what that SPIRE agent would be able to do, which is pretty restricted. And reliable, because that SPIRE server would be a single point of failure if you only had one of them. So one of the major areas that the SPIRE contributors are working on is different ways to make it more reliable, including high availability, nested SPIRE servers, so you could have one master SPIRE server and many sub-SPIRE servers in order to handle different trust domains, and federation between SPIRE servers. So you could have two different SPIRE servers that are loosely coupled and they share some information, but not everything. And that way, if one goes down, it doesn't necessarily affect your entire system. All right, and now I'm going to pass it back to Tyler, and he's going to do what we call a case study, sort of an example of how a company that's growing could end up with an identity problem that needs SPIFFE and SPIRE to solve.
Cool, now I got this one. Cool, so just checking how we're doing on time here. So we've talked a lot about the background at Uber, what our infrastructure looks like. We've talked about what we look for from identity. And we've talked about how SPIFFE and SPIRE solve the problem of identity. But you might be asking, do I need identity? I don't know, maybe, maybe not. I want to tell a story about a system that starts rather small and simple, and as the business requirements change, so do the system. And as that system evolves, so does the data model and the data access. And as that data access changes, so do the policies and the security policies need to evolve. What identity might allow you to do is to evolve more quickly with that security policy. So we start in the beginning, in the early stages of a system. It's so simple. You have a user's database that might include riders and drivers. You have a couple services that need to talk to it. You've got a matching service that might pair a rider with a driver. You've got a trip service that might manage the life cycle of a trip from beginning to end and track GPS points or something like that. And you've got a payment service that might charge the rider and pay the driver. They need access to your data store. So in the beginning, the simplest solution seems to be the tried and true username and password. That seems to work. Now what do? Do you have a unique username and password for each service, or do you share them? Well, there's trade-offs, and the trade-offs might depend on what your business wants to do. If you're sharing those credentials, man, it's pretty easy on your service owners. All they got to do is find out where that username and password is and provision their service, and they're good to go. If you need to create new credentials for each service that comes up, now you've created developer friction in the name of security, right? And that might be fine. But it might slow down your developers. They might not like that. But then again, if you're sharing a username and password, you lose a bit of attribution. You lose a little bit of, I don't really know who's making these queries. And that's a problem from a reliability perspective. Now think about, as you start to scale these services, right? You're going from 3 services to 10 services to 20, 100. This starts to not look very good, because if you decide to have a credential, to have one credential per service, you have a credential management problem where you need to think about revocation, rotation on a much larger scale. And not only that, but just here we see that the payment service only needs 1 credential, but it needs 1 credential per database that it's talking about, or that it's talking to. So the number of credentials starts to scale with the number of edges in the graph of services to data stores, and not with the number of nodes. So this very quickly becomes an intractable problem. Right, so what do? You're in, your company's growing very fast. You decide to implement an API gateway. Look at that, you only have 1 credential now. That's a very tractable problem. All the folks who were writing garbage queries that were making your database fall over, you can now limit them at the gateway. You've solved your instrumentation problem. Things are looking quite good, right? All the access is coming through a single gateway. You can even start to fine-tune your ACLs so that the trip service can access payment data. But you now have a new problem, which is, how do all these services authenticate to the gateway? You could provision them all with public keys, but that's a rather difficult task when you're in hypergrowth. So someone suggests, well, we're inside our own secure perimeter. Why don't we use the name tag approach? That seems fine. Every service could just say, hey, I'm the matching service. And we're in our secure perimeter, and we have bastions and all that, so maybe this is fine. And it seems fine, right? Until you start to realize that your secure perimeter is no longer really a secure perimeter. Number one, either because you started to see insider threats because the number of services had grown so large that you really can't monitor every little thing. Or you go through a migration. Later on, you've realized that your first API gateway didn't scale so well, or maybe you've run out of compute and you need to move to a new cloud or new region or what have you. But this type of thing is not uncommon. So then what do? You start migrating your services over, and you're using your tried and true name tag approach, and things seem to be going good. What happens when you realize you got a misconfiguration somewhere? Or perhaps, as bad as it could be, maybe you have a bad actor somewhere. I like to prefer bad configuration because that's more common in my experience. So you got a service out there that's saying that they're the payment service, but they're not the payment service. And this kind of thing can be very hard to track down, to solve. So what does SPIFFE and SPIRE get you? It gets you secure, cryptographically provable identity to solve this type of problem. Now, you don't have to worry about assuming that your services are acting the right way. You have the proof. You have cryptographic tokens, or you have cryptographic documents that prove identity. And so by reducing the amount of trust in your system, you've reduced your assumption of behavior. Now, that's a good thing for the reliability of your system and the security of your data. So where's Uber at right now? We've progressed quite a bit from the early days. Right now, SPIRE is a core component in our next-gen infrastructure that we're building out. And it's also being deployed with a sidecar that we're using in our legacy stack. You've seen a lot of stuff about service mesh. We're using a sidecar approach to sort of retrofit authentication onto our infrastructure. What this cloud-native approach allows us to do is that regardless of the infrastructure, regardless of where these applications are running, this identity acts as a bridge between those things. And so this is very powerful. So we talked a lot about why we decided to implement identity at Uber. I wish I had more time for exactly how. But what we're hoping to be able to do at the next KubeCon is actually go through some of the lessons we've learned from working with SPIFFE over the last year and deploying SPIRE at scale. Bring us home.
Great. Yeah. Thanks, Tyler. And this is our last slide. If you take away anything from this talk, this is what we'd like you to take away. If you have SPIFFE and SPIRE, that enables you to do workload authentication. And if you can do workload authentication, you can do authorization. There are lots of different ways to do that. And once you have authorization, your services, your data are safe. And you can check out spiffe.io to find out more. And now we have some time for questions. Just raise your hand if you have a question, and I'll come over with the microphone.
Thank you for the talk. In the initial diagram, you showed a new workload requesting its identity documents from the SPIRE identity provider. Right? How do you seed that with initial credentials so that just no one can just randomly request such documents?
There's a chain of trust starting from when you initially set up the node, and we call that node attestation. And you have to do that somehow. The easiest way is by copying a token. Next question? Oh, any more questions?
All right. Be sure to, I think we were asked to make sure you guys rate the talk on Sked.
Yes.
Sketch.
Please rate us on Sketch. Smiley face, unless you have a frowny face. All right, cool. And I guess we're done with the conference.
Have a good KubeCon.
Congratulations, everyone. Enjoy Barcelona.